This is a couple examples of how to use inverse trigonomic functions. First here we have a sine inverse of negative square root of 2 over 2. Now one thing you want to get used to is this is what's called a rationalized form, and for our purposes it's not exactly the best. The ones we're used to are things like square root of 3 over 2, 1 over square root of 2, stuff like that. But square root of 2 over 2 is not a special triangle, and we need to get it into the special triangle numbers, which are 1, square root of 2, and 2. So for this one, I'm going to unrationalize it. So let's see, square root of 2 over 2. To unrationalize it, you're going to multiply top and bottom by the square root of 2. So this becomes 2 over, square root of 2. 2 over 2 square root of 2, better known as 1 over square root of 2. Alright, the second thing we have to take care of is the sign. I need to know when the sine function is negative, which quadrant sine function is negative. And if we do the all students take calculus thing, I know that the sine function is negative in the third and the fourth quadrant. But the sine inverse function only works in the first and the fourth. So this angle, remember this is the ratio, and we're looking for the angle of what makes square root of 2 over 2 negative. So what I'm going to do is I'm going to draw a little coordinate system. And I'm going to put an angle in the fourth quadrant. So if I put an angle in the fourth quadrant and then draw its reference triangle, this is where they come in kind of handy, I can label the sides. This would be opposite. This would be hypotenuse. So opposite would be over here if this is our angle theta. Opposite would be 1, and it's going to be negative because it's going down, and then the hypotenuse is square root of 2. Well, angle theta then has to be 45 degrees because this is the special triangle 1, 1, square root of 2. But it's not just 45 degrees, we're going down with it. So this thing is going to equal negative pi over 4, or negative 45 degrees. So sine inverse of negative square root of 2 over 2 is negative pi over 4. Alright, same thing with this cosine inverse of 1/2. Remember, 1/2 is the ratio. Cosine inverse of a ratio is going to give us some angle. So basically this whole thing is theta. This doesn't have to be rationalized or anything. This is just a special triangle setup, 1/2. Cosine is adjacent over hypotenuse. And all I need to do is draw a coordinate system and put the angle in the right location. And do this one in red. Now the coordinate, or the quadrant that it has to be in, when is cosine positive? Well, cosine is positive in the fourth quadrant and the first quadrant. But cosine inverse is only defined in quadrant 1 and quadrant 2. That's the only places it's defined. So to be positive, it has to be in quadrant 1. So I'm going to draw my reference triangle in quadrant 1. Oops. And then just label the sides. Call the angle theta. It's adjacent over hypotenuse, so this is 1, this is 2, the third side. Special triangle, it's square root of 3. The angle that theta has to be with square root of 3 across from it is 60 degrees. So that would be pi over 3. So this is equal to pi over 3, the angle. So cosine inverse of 1/2 is pi over 3. Alright, if we use tangent inverse. Again, this is a rationalized form of a square root of 3. We don't have a special triangle that has square root of 3 and 3 in it. So I'm going to irrationalize it, unrationalize it, and multiply top and bottom by square root of 3. So that'll give us 3 over 3 square roots of 3, better known as 1 over square root of 3. So I'm going to change this from square root of 3 over 3 to 1 over square root of 3. And then we're going to say, well, when is tangent negative? Well, tangent is negative let's see, all students take calculus. Tangent is negative in the second or the fourth quadrant, but tangent inverse is only defined from negative pi over 2 to pi over 2, so first and fourth quadrant. So this angle has to be in the fourth quadrant. So if I draw out my little axes and put some angle in the fourth quadrant, draw a reference triangle for it, call that angle theta, and label our sides appropriately. Now this is a tangent, so this is going to be opposite over adjacent. So opposite is 1, and it's going to be negative because of that negative sign. And this side is adjacent, so that'll be square root of 3, and that leaves 2 for the other side. And what angle is across from the 1? Well, that's going to be 30 degrees. But it's going down, so it's going to be negative 30 degrees. So this will be negative pi over 6. So the tan inverse of negative square root of 3 over 3 is negative pi over 6. Alright, and then down here with this one is a secant inverse, but I highly suggest you don't work with secant inverse. It's easier to work with sines, cosines, and tangents. So all you have to do is recognize that secant is 1 over cosine. So if I change this into cosine inverse, and since this is the ratio, I just need to take the reciprocal of the ratio. So that would be negative 1 over square root of 2. Perfect special triangle setup. And again, we can say, when is cosine negative? Well, cosine is negative in the second and third quadrants. But cosine inverse only works in the first and the second. So this angle has to be in the second quadrant. So I'll draw out my coordinate axis. And I'll draw my angle in the second quadrant. There's my angle. Draw my reference triangle. Call the reference angle theta. And label my sides. Now cosine is adjacent over hypotenuse. So the adjacent is going to be negative 1. The hypotenuse, always positive, is going to be square root of 2. The third side has to be 1. This is a 1 over square root of 2, so it would be 1 square root of 2. So this angle here, the reference angle, is pi over 4. But that's not the answer to a second quadrant angle. We have to open it up from the initial side to that side. So if the reference angle is pi over 4, the original angle must have been 3 pi over 4. So the answer to this one is the secant inverse of negative square root of 2 is 3 pi over 4. The angle associated with that. That's it.